Now we're going to look at how to solve equations that contain rational exponents, in other words, fractional exponents. So to solve an equation with rational exponents, what we want to do is raise both sides to the reciprocal power so that the exponent on the variable expression will become a 1. Now, if you raise both sides of an equation to a power that has an even denominator, then you're essentially taking the square root of both sides, which means you're pretty much using the square root property, and you have to insert that plus minus symbol in front of the right side, and you need to check the solutions. These equations are not actually that difficult to solve, so once we've got a couple of examples under our belt, you'll probably feel a lot better about it. So let's get to some examples now. Here we have x to the 3/5 power equals 27. So you see this exponent 3/5. We would like for that exponent on that variable to be a 1. So what we're going to do is raise both sides to the reciprocal power. So I'm going to raise both sides to the 5/3 power. Now notice that here we would apply the power rule for exponents, and when you multiply 3/5 times its reciprocal, you do get 1. So the left side is going to simplify to just x. Now for the right side, I'm going to evaluate this the way that we learned to evaluate them back in the R chapter at the beginning of the course. So I'm going to write this as cube root of 27 raised to the 5th power. Now you know the third root of 27 is 3, so that's going to give us x equals 3 to the 5th power, and you can multiply that out or use your calculator to see that 3 to the 5th power is going to be 243. And now let's check our solution by plugging 243 back into the original equation. So again, I'll write this with radical notation, so it's going to be 5th root of 243 raised to the 3rd power equals 27. Well, let's see. The 5th root of 243 would be 3. And then that says 3 to the 3rd power equals 27, which we know is true. So this solution does check, and we find that x equals 243. Here is a similar equation, same type of equation, but notice that this time instead of just the variable being raised to a power, we have a variable expression. But we still will solve it by the same method. So what we want to do is eliminate this exponent. So we will raise both sides of this equation to the reciprocal power. So that means raising both sides to the 3/2 power. Now notice that we are raising both sides to a power that has an even denominator, so we're going to need to insert that plus minus symbol there. Remember, whenever you're raising both sides to a power that has an even denominator, you're basically applying the square root property, and you're going to have to insert that plus minus. Okay, now over here on the left, these exponents multiply together and become 1. So the left side just simplifies to x minus 4. Over here on the right, this 2 in the denominator means that we're doing the square root of 16. So I'm going to write this as plus or minus the square root of 16 raised to the 3rd power, because the top of our exponent is 3. Okay, now the square root of 16 is 4, so that's going to give us x minus 4 equals plus or minus 4 to the 3rd power. And now let's go ahead and evaluate that 4 to the 3rd power. We know 4 to the 3rd is 64. So we have x minus 4 equals plus or minus 64. Let's add 4 to both sides, and that gives us x equals 4 plus or minus 64. So we need to work both of these possibilities out. If we use the plus sign, 4 plus 64 will give us 68, and if we use the minus sign, 4 minus 64 will give us negative 60. So now we will check both of these solutions in our original equation. Let's check the 68 first. So if we plug in the 68, we're going to get 68 minus 4 equals 64. So now the left side says 64 to the 2/3 power. And now we're going to write this in radical form. So this is going to be 3rd root of 64 all squared. Okay, the 3rd root of 64 is 4. So now the left side is 4 squared, which is 16. And that does check. So the solution 68 is a good one. Now let's check negative 60. So if we plug negative 60 in here, we're going to get negative 60 minus 4 to the 2/3 power equals 16. Now negative 60 minus 4 is going to be negative 64. So now we have negative 64 to the 2/3 equals 16. And now we're going to write this in radical form. So we're going to have the cube root of negative 64 all squared. Now you know that you can do the cube root of a negative number because a negative raised to the 3rd power is still negative. So the cube root of negative 64 is going to be negative 4, and that's going to give us negative 4 squared, which is positive 16. So this solution also checks out. And our solution is that x equals 68 and negative 60. Okay, I'm sure there will be times when you want to evaluate rational exponents using your calculator instead of doing it mentally. Now, you need to understand how to do it mentally, and you cannot just rely solely on the calculator, or it will lead you astray. But I do want to take a few minutes and make sure you know how to enter these rational exponents in the calculator, and so you can see some of the pitfalls that are out there if you don't know what you're doing. The problem is that, especially this model of scientific calculator, has something in its programming that does not allow it to deal correctly with negative bases that are being raised to rational exponents. So I want to show you how to enter this in the calculator whether you've got a positive base or a negative base. Let's start with the positive base. So here we have 64 to the 2/3 power. And so this is the power button. It looks like a little house top there. It's a caret symbol. And so we say 64 to the power 2/3. Now the problem is if you just enter 2/3 into the calculator, it looks to you like you're saying 64 to the 2/3 power, but the calculator understands order of operations. So what the calculator sees is 64 to the 2nd power, get that answer first, and then divide by 3. And it does not consider the 3 as part of the exponent, which is what you want. So what we're going to do is use parentheses. So we'll say parentheses 2 divided by 3. Now this will work. You can close the parentheses if you like, but if you press enter, the calculator will automatically close the parentheses for you. And you can see the answer is 16, just like we got on the last slide when we checked it using radical notation. Now I also want to show you that you can use the fraction button instead of the division key. Either way, it doesn't matter, you're still doing 2 divided by 3. So if I say 2 fraction 3, it's still going to work, so that's great. Now let's see about putting in negative 64 to the 2/3. So I put my negative 64 in parentheses so that the calculator knows that the negative is being raised to the 2/3 power, and that's as it should be. And then I say power parentheses 2/3, and go ahead and close it if you want to, and then enter, and it gives me a domain error. And again, there's something in the calculator's programming that is keeping it from dealing with rational exponents on negative bases the way it should. If you really want to do this on a calculator, you have to do it in 2 steps. You have to pretty much do it the way we did it when we were using the radical notation on the last slide. The trick is to separate the 2/3 exponent into 2 parts. So we have negative 64 to the 1/3, that's going to give us the 3rd root. And then we take that answer and raise it to the 2nd power. That takes care of the 2 in the numerator. That's pretty much what we did when we checked it ourselves previously, but we wrote it in radical form instead of the rational exponent form that I have here. But the calculator will handle this just fine. It seems to be the 2 that it has a problem with. So now if I say parentheses negative 64, close the parentheses, to the power 1/3, and press enter, the calculator can handle that, and it gives me negative 4. Now if I raise that to the 2nd power, then I get positive 16. And note that here, instead of saying raise to the 2nd power, I could have also just used the square key. But if I'd had any other number in the top of the exponent, of course that square key wouldn't work and I would have to specify the power using the caret key. But splitting the exponent up like this is the way to get around this problem, and again it only happens when your base is negative. And don't you think that this is just a little too much sugar for a nickel? Honestly, if you know how to evaluate these mentally, you really don't even need the calculator. So I'm not encouraging you to depend on the calculator. On the contrary, I'm saying it's better for you to understand how to do it yourself, because the calculator is kind of a drag here unless the numbers are just really large and strange to you. Now the next two equations are just practice problems. You should be able to work them on your own. So for each of the next two, I would encourage you pause the video and try it yourself and then check your work with me when you've finished. Let's go through this one together. Here we have x to the 3/2 equals 125. So we know that we want to eliminate this exponent, and we know the way to do that is to raise both sides to the reciprocal power. So I'm going to raise both sides to the 2/3 power. Now, do I need a plus minus in front of this? The answer is no, I do not need a plus minus, because the exponent that I'm raising both sides to has an odd number in its denominator. We only have to put the plus minus when the denominator of the new exponent is an even number. So I'm only going to have one solution here. On the left side, the 3/2 power raised to the 2/3 power becomes 1. 3/2 times 2/3 is 1. So on the left side, we just get x. On the right side, let's separate this into the radical notation. So we're going to have the third root of 125 raised to the second power. Now we know that the third root of 125 is 5. So now we have x equals 5 squared. And of course 5 squared is 25. So 25 is our potential solution. Let's plug it back into the original equation and check it. So we're going to have 25 to the 3/2 power is supposed to equal 125. So let's see if it does. So we're going to say that the left side is the square root of 25 raised to the third power. And then, of course, square root of 25 is 5. So we have 5 raised to the third power. And then, of course, that evaluates as 125. So that does check. And our final solution is x equals 25. Now, here is the last equation of this type that we'll work on together in this section. And so we have here x minus 3 raised to the 2/5 power equals 4. And remember, you ought to pause the video and try this by yourself before you watch the solution. Okay, now I'm going to go through the solution with you. So we can see that the exponent expression is already isolated. It's already by itself on the left side of the equal mark. So the way to eliminate this exponent is to raise both sides to the 5/2 power. Now remember that because we're raising both sides to a power that contains an even denominator, we are required to insert that plus minus symbol. So again, raising both sides to a power that has an even denominator is very much like using the square root property. So for the same reason, you have to insert the plus minus. Now notice over here on the left that the 2/5 power raised to the 5/2 power means we multiply these exponents together, and that will make the exponent a 1. So all we have remaining on the left side is x minus 3. Now on the right side, we do have the plus minus, and we're going to have 4 under a square root radical, and we're going to have that radical raised to the 5th power. So let's go ahead and evaluate that. The square root of 4 would be 2, and then 2 to the 5th would be 32. So right now we have x minus 3 equals plus or minus 32. So we add 3 to both sides to isolate the x, and we're going to have x equals positive 3 plus or minus 32. So we'll need to work out both of these solutions. 3 plus 32 is going to make 35, and 3 minus 32 is going to make negative 29. Now, a mistake that I see students make sometimes is they want to enter their answer into MyLabs Plus this way. And this is correct, but it's not the final simplified form of the answer, because we can do 3 plus 32 and we can do 3 minus 32. So there's no reason to leave it in this form. It's up to the person working the problem to put the answer in the simplest form possible. which is not this, but 35 and negative 29. And now we have to check both of these solutions. So if I plug the 35 in here, I'm going to have 35 minus 3 raised to the 2/5 power equals 4. Okay, 35 minus 3 is 32. So now I have 32 to the 2/5 power. And now I'm going to write this in radical form. So I'm going to say the 5th root of 32 all raised to the 2nd power, because 2 is the top number in our exponent. Okay, the 5th root of 32 is 2. So this says 2 squared, and we know that that is 4. And we can see that's going to match the right side of our equation. So now we know that 35 is a good solution. And let's also check negative 29. So plugging in the negative 29, we'll get negative 29 minus 3 raised to the 2/5 power equals 4. Okay, negative 29 minus 3 makes negative 32. So now we have negative 32 to the 2/5 power. And if we write this in radical notation, we'll have 5th root of negative 32 all raised to the 2nd power. Now the 5th root of negative 32 needs to be negative 2. So now I've got negative 2 squared, and of course negative 2 times itself is positive 4. And again, that matches the right side of our equation. So this solution checks as well. And our final solution here is x equals positive 32 and negative 29. Now let's look at the last type of equation that we're going to see in this section, and that is equations quadratic in form. So an equation is said to be quadratic in form if it can be written like this, where you have a second power term and a first power term and a constant term, and you can write them all on the same side of the equal mark so that the right side is 0. Now the first power term and the constant term can be 0. That is, they may not appear, but of course you have to have a second power term or you don't have anything quadratic to work with. Now the thing to notice about quadratic equations is that the power of the first term has to be twice as much as the power of the middle term. So, if you could see the exponent here, it would be a 1. And so 2 is twice as much as 1. So any equation that has the property where the first term's power is twice as much as the second term's power, we can always think of those as a quadratic equation in order to get them solved. So look at this equation. It looks absolutely horrible. It says x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2 equals 0. And you look at something like this and you just throw up your hands and you say, oh my gosh, I would know what to do if it were a quadratic equation, but I don't know what to do with these fractional exponents. This looks really hard. Well, the key here is to make a substitution that will make it look like a quadratic equation. So notice that the exponent on the first term is twice as much as the exponent on the second term. That's the most important thing here. 2/3 is twice as much as 1/3. And so now remember that these parentheses would have coefficients of 1. I'm going to go ahead and write those in there. But now what we're going to do is just make a substitution so that this whole expression gets replaced by just one letter. So it looks very simple. So I'm going to say that u equals x plus 1 to the 1/3. Well, if u equals x plus 1 to the 1/3, then when you look at this term that has a power twice as big, this has to be u squared. So now we get to say 1u squared minus 1u minus 2 equals 0. So let's write it that way. U squared takes the place of x plus 1 to the 2/3. And u takes the place of x plus 1 to the 1/3. And then we have the minus 2 equals 0. Now, this is just a very simple quadratic equation that we can solve by factoring. So let's break this into two binomials. And u squared is going to become u times u. And then the signs in the binomials need to be different. So I'm going to put down a plus and a minus. And then last times last is 2. So I'm going to use 2 times 1. But I'm going to put the 2 here so that the outer plus inner will add up to the negative 1u that we need. Okay, so let's see. If this times this equals 0, then one of these factors has to be 0. If u plus 1 is 0, then u equals negative 1, and if u minus 2 is 0, then u equals positive 2. Now don't stop here because it looks like we're finished, but we're not quite. These are the u values that solve this equation, but remember our job was to solve this equation. So now we have to use this relationship to go from u back to x. So for each one of these solutions, I'm going to plug the u value back in here. So let's start with negative 1. So instead of u equals x plus 1 to the 1/3, I have negative 1 equals x plus 1 to the 1/3. Now this is nothing more than just one of those rational exponent equations that we were just working just a few minutes ago. So the way to eliminate this exponent is to raise both sides to the reciprocal power, which is going to be 3. So I'm going to raise both sides to the third power. Negative 1 to the third power is negative 1. And then when we have 1/3 power raised to the third power, of course, that gives us an exponent of 1. And the right side just becomes x plus 1. Now if I subtract 1 from both sides to solve, I get x equals negative 2. Let's do the same thing for this second u solution. So plugging the 2 in place of the u, I'm going to have 2 equals x plus 1 to the 1/3 power. Okay, so again, raise both sides to the third power, and 2 to the third power is 8. So now we have 8 equals x plus 1, because over here the exponents multiply together and make a 1. Now subtract 1 from both sides and we get x equals 7. So our two potential solutions are negative 2 and 7. And of course we do need to check these. So let's just take the negative 2, plug it back into the original equation. Now it won't really be as difficult as you think, because when we plug the negative 2 in here right away we can do a little evaluation. Negative 2 plus 1 is negative 1. So this term becomes negative 1 to the 2/3 power. And this term becomes negative 1 to the 1/3 power, and then we have minus 2 equals 0. Okay, now the third root of negative 1 is negative 1, and negative 1 squared is positive 1. See, I'm doing the same thing we did before where we wrote it in radical notation. I'm just not actually writing down the radical notation. We're just doing this mentally. The third root of negative 1 is negative 1, and then negative 1 squared is positive 1. Okay, now we're going to have minus negative 1 to the 1/3. Okay, the third root of negative 1 is, again, negative 1. And then we have minus 2 equals 0. Okay, now here we have minus negative 1, so of course that's plus 1. So we have 1 plus 1 minus 2 equals 0. And of course 1 plus 1 is 2, and 2 minus 2 is 0, so that checks. And now let's check the 7. So 7 plus 1 is going to be 8. So I'm going to have 8 to the 2/3 minus 8 to the 1/3 minus 2 equals 0. Okay, start with the root. The third root of 8 is 2, and 2 to the second power is 4. And again, start with the root. The third root of 8 is 2, and 2 to the first is still 2. And then we have our minus 2 equals 0. Okay, so let's see. 4 minus 2 is 2, and 2 minus 2 is 0, so that checks. And we have two good solutions here. X equals negative 2 and positive 7. Here is a really simple one that says 6x to the negative 2 plus x to the negative 1 equals 2. Now, is it possible to use the negative exponent rule to put these two things down in the denominator and then clear denominators? Yes, that is possible, but I want to forewarn you that on the quiz, the instructions are going to require that you use this substitution method that I'm showing you, because this skill of substituting one thing for another is a very important skill going forward in math. Not just algebra, but business calculus or calculus if you're headed that direction. So I'm going to stick with the substitution method that I showed you before because I want us to get a little more practice at it. So again, notice that the leading term's exponent is twice as much as the second term's exponent. And that means we're going to be able to make a substitution that will make this look like a quadratic equation. So it's always the middle term that you substitute. So first I'm going to remember that this coefficient is a 1, but I'm going to let x to the negative 1 be u. So the u is x to the negative 1. That makes this u squared. So now I have 6u squared plus 1u equals 2. And of course, you can see it's a pretty simple quadratic equation now. I'd want to try to solve it by factoring, so I'll bring the 2 to the left side. So that's going to be 6u squared plus u minus 2 equals 0. Now let's factor this into two binomials. So 6u squared can break down into 3u times 2u. The signs in the binomials need to be different. And do I know for sure that these signs are in the right place? Right now I do not, but what you have to do is just put them in there and know that at the end, if they need to be swapped, you'll know it and you'll be able to swap them. Okay, now last times last is 2. So I know that the only two numbers that multiply together to make 2 are 2 times 1. And I also know that I can't put the 2 here because if there were a 2 here, it would create a GCF in this parentheses, and I'm not supposed to have a GCF. So I'm going to put the 2 here and the 1 here. And now let's check to see if outer plus inner adds up to the middle term we need. Outer times outer is going to be minus 3u. Inner times inner is going to be plus 4u. Negative 3u plus 4u does add up to positive 1u, so that's what we wanted, so this is good. All right, now, if this times this is 0, one of these has to be 0. Either 3u plus 2 equals 0 or 2u minus 1 equals 0. If 3u plus 2 equals 0, then 3u equals negative 2 and u equals negative 2/3. But if 2u minus 1 equals 0, then 2u equals 1 and u equals 1/2. Now remember, these are not our final solutions because these are values of u, but u was just a variable that we used as a substitution for the real thing that we want. And so u equals negative 2/3 means that negative 2/3 equals x to the negative 1. All right, now what is a negative 1 exponent besides an indicator for a reciprocal? All we're going to end up doing here is turning this over, but you can raise both sides to the negative 1 power just to show it. And then negative 2/3 to the negative 1 power is going to be negative 3/2. And of course, over here, the negative 1 power raised to the negative 1 power means we just have x on the right side because negative 1 times negative 1 is positive 1. Okay, so this is one of our x values. You can know in advance that the second one is going to be 2 because the reciprocal of 1/2 is 2, but let's go ahead and show it. If u equals x to the negative 1, then 1/2 equals x to the negative 1. Raise both sides to the negative 1 power, and of course it makes a reciprocal on the left side, and we get x equals 2. Now let's check. So I'm just going to go back to my original equation and plug in the negative 3/2. So I'm going to have 6 times negative 3/2 to the negative 2 plus negative 3/2 to the negative 1, and that's supposed to equal 2. You could very quickly enter this on your calculator, but just for the practice of it, let's go through it together. Remember that the negative means that these are going to get flipped, and the 2 means that we're going to square each of these numbers. So if I square negative 3, I get 9, and if I square 2, I get 4, and then because of the negative exponent, I'll flip this, so I'm going to get 6 times 4 over 9. Now for this term, the negative 1 exponent just means that this gets flipped. Of course, it keeps its sign. So when I flip this over, I get negative 2/3, and plus negative 2/3 just gives me minus 2/3. Now let's do this multiplication, and then we'll do the subtraction, and we should come up with 2. Okay, when we multiply the 6 times the 4/9 here, the 6 and the 9 can both be divided by 3, so we'll do that. 6 divided by 3 is 2, and 9 divided by 3 is 3. That's going to give me 2 times 4/3 minus 2/3. Now, 2 times 4/3 is 8/3. So now I have 8/3 minus 2/3. Of course, that's 6/3, and that simplifies to 2, which matches our right side, so this is a good solution. And let's go ahead and check the 2. So this says 6 times 2 to the negative 2 plus 2 to the negative 1 equals 2. Okay, 2 to the negative 2 means that we square the 2, but then we flip it. So 2 squared is 4, but then when you flip it, it's going to be 1/4. So I'm going to have 6 times 1/4, which is 6/4. And then here I'm going to have plus 1/2. And now we need a common denominator to add these together. So 1/2 becomes 2/4. So now we have 6/4 plus 2/4, that's 8/4, and that also simplifies to 2. So this solution also checks. Now here's one that you can practice on by yourself. So I would encourage you to pause the video and try it yourself, and then I'll go through it with you. Okay, here we go. So we have x plus 1 to the 2/5 power minus 3 times x plus 1 to the 1/5 power plus 2 equals 0. Notice that the exponent on the leading expression is twice as much as the exponent on the middle term. So that's our clue that we can make a u substitution here. So we always let u equal the variable expression from the middle term. So it's going to be u equals x plus 1 to the 1/5 power. If this is u, then that makes this leading expression u squared. So now I'm going to write u squared minus 3 times u plus 2 equals 0. This is quadratic now, and we can factor it into two binomials. So u squared becomes u times u. The signs in our binomials need to be the same, and they both need to be minus. And last times last is 2. So we have to use a 2 and a 1, and it doesn't matter which one goes where. I'll just put them like this. Okay, now make sure that outer plus inner adds up to the middle term that you want, and it does. If this times this equals 0, then one of these binomials has to be 0. Either u minus 2 equals 0, or u minus 1 equals 0. If u minus 2 equals 0, then u equals 2. If u minus 1 equals 0, then u equals 1. But these are not the final solutions because these are u values, and our original equation was in x's. So we need to now use these two solutions with this relationship to go back and find x. Okay, remember u equals 2, but u equals x plus 1 to the 1/5. That means 2 equals x plus 1 to the 1/5. See, I'm just putting the 2 in place of the u so I can get back to x. Now raise both sides to the 5th power, and we'll have 2 to the 5th, which is 32, equals x plus 1. Subtract 1 from both sides, and you have x equals 31. That's one solution, and now let's get the solution for u equals 1. So 1 equals x plus 1 to the 1/5 power. And we'll raise both sides to the 5th power, and 1 to the 5th power is 1. So now we have 1 equals x plus 1. Subtract 1 from both sides, and you just have x equals 0. Now, both of these should check, so let's run through the checking real fast. So if I want to check 31, I go back to the original equation, and I plug in 31. 31 plus 1 is 32, so I'm going to have 32 to the 2/5 power minus 3 times 32 to the 1/5 power plus 2 equals 0. Now, we can do this really fast mentally. The 5th root of 32 is 2, and 2 squared is 4. On this middle term, the 5th root of 32 is 2. So I'm going to have 4 minus 3 times 2 plus 2. Now, remember, order of operations says we have to do multiplying first. So 3 times 2 is 6. So now I have 4 minus 6 plus 2. 4 minus 6 is negative 2, and negative 2 plus 2 is 0, and that matches the right side of our equation, so 31 checks. Let's check 0. So if I plug 0 in here, 0 plus 1 is 1, so I have 1 to the 2/5 power, minus 3 times 1 to the 1/5 power, plus 2 equals 0. Now the 5th root of 1 is 1, and 1 squared is still 1. So this says 1 minus 3 times 1 plus 2 equals 0. 1 minus 3 is negative 2, and negative 2 plus 2 is 0. So this one also checks. And our final solution is x equals 31 and 0. And here is just one more similar example for you to practice on. And again, I would encourage you to pause the video and try it on your own, and then we'll go through it together. So if you've tried this by yourself, let's go through it now. So notice that the variable that I have here has an exponent twice as much as the variable that I have here. That means I can make a u substitution. So remember, it's always the variable expression from the middle term that we use to substitute u for. So we're going to let u equal x to the negative 1. That means u squared will represent this part. So we're going to get 10u squared plus 33u minus 7 equals 0. Okay, now we have a quadratic equation, and let's try to solve this by factoring. So we're going to break this into two binomials. U squared can probably be written as 5u times 2u. The signs in our binomials will need to be different, so I'm just going to put a minus and a plus. I will know if I need to switch these around later, but for now this is fine just as long as they're different. Okay, last times last has to be 7, so I'm going to have to use 1 times 7. Let's arrange the numbers like this and see if we get the middle term that we want. So outer times outer would be 35u, inner times inner would be minus 2u. 35u minus 2u is 33u. So this factoring is correct, so now we can solve for u. If this times this is 0, one of the factors has to be 0. Either 5u minus 1 equals 0, or 2u plus 7 equals 0. If 5u minus 1 equals 0, then 5u equals 1, and u equals 1 over 5. But if 2u plus 7 equals 0, then 2u equals negative 7, and u equals negative 7 over 2. Now we have to translate these u solutions back into x. So we'll use this relationship, and we'll take u equals 1/5 first, and we'll put the 1/5 in place of the u here. So instead of u equals x to the negative 1, we have 1/5 equals x to the negative 1. Remember, the negative 1 exponent just indicates a reciprocal, so we know this is going to be 5, but let's just show it algebraically. So we'll raise both sides to the negative 1 power, and that's going to give us x equals 5. And we'll do the same thing with the negative 7 over 2. So negative 7 over 2 equals x to the negative 1. Raise both sides to the negative 1 power, and then we have negative 2/7 equals x. So these are our two solutions, and now let's just check quickly. So we'll check the 5. That's going to give us 10 times 5 to the negative 2 plus 33 times 5 to the negative 1 minus 7 equals 0. Okay, now for 5 to the negative 2, what we have to do is square the 5 and then flip it into the denominator and then multiply it by 10. So 5 squared is 25. Flip it into the denominator, we have 1 over 25, and then multiply it by 10. So this first term is going to be 10 over 25. For the second term, we raise the 5 to the negative 1 power. In other words, we flip it down to the denominator and multiply it by 33, and we get 33 over 5. And then we have minus 7 and then equals 0. So we need to add this up and verify that it does equal 0. Now, without going through too much fuss, we can realize that this fraction can be simplified. And if you divide both of these numbers by 5, you're going to get 2 over 5. So if we have 2/5 plus 33/5, that's 35/5, which simplifies to 7. 35 divided by 5 is 7. And then 7 minus 7 is 0, so this does check. And now let's quickly check the negative 2/7. So we're going to have 10 times negative 2/7 to the negative 2 power plus 33 times negative 2/7 to the negative 1 power minus 7 equals 0. Okay, just like before, we know that this negative 2 exponent means that we square each of these numbers, and the negative means we flip. So we'll get a reciprocal there and multiply by 10. So let's see. If we square negative 2, we get positive 4. If we square 7, we get 49. So if we take 4 over 49 and then flip it, it's going to be 49 over 4. And then we'll do pretty much the same thing here, except we don't square because it's a negative 1 power. So just flip this and we'll have plus 33 times negative 7 over 2 minus 7 equals 0. Now the easiest thing to do probably at this point is just take a calculator and multiply 10 times 49/4 plus 33 times negative 7/2 minus 7 and press enter and just verify that it does equal 0. It does. And so we can now confidently say that the solution here is 5 and negative 2/7. Now I just want to give you a little reminder here that the big mistake most students make on these problems is when they find their u solutions, they just stop. That's not right, because the equation that you'll be given will be in terms of x. So if you make a u substitution and you find the solutions as u, you then have to substitute back like we've done every single time. Just don't forget, at the end you have to be able to say x equals, not u equals. Now here's just one more example, and we're going to work this two different ways because I do want you to see that substitution is not the only way. However, for this course you will be required to use substitution when you show your work on a quiz, but there might be other problems where you're not required to show your work and you might want to work it a different way. So I'm going to show you both ways for this particular problem. Here we have 12x to the fourth minus 11x squared plus 2 equals 0. And let's just notice that the exponent on the leading term is twice as much as the exponent on the middle term. So that means we can make a u substitution, and u will be x squared. So if u represents this, then u squared will have to represent this. So we're going to get 12u squared minus 11u plus 2 equals 0. This is something we can factor. So I'm going to try to break it into two binomials. 12u squared will become 3u times 4u. The signs need to be the same, both negative, and last times last is 2. So I need to do a 2 times a 1. Notice I couldn't put the 2 here because that would have created a GCF in this parentheses, and this trinomial does not have a GCF. Now I need to verify that outer plus inner is going to add up to negative 11u. So let's see, negative 3u minus 8u does add up to negative 11u, so this is good. All right, now, if this times this is 0, one of these has to be 0. Either 3u minus 2 is 0, or 4u minus 1 is 0. If 3u minus 2 equals 0, then 3u equals 2, and u equals 2/3. If 4u minus 1 is 0, then 4u equals 1, and u equals 1/4. Now, we have found solutions, but these are u solutions. So always remember, you have to get back to x. So we'll need to take our 2/3 and our 1/4 and put them back in this relationship. So if u equals x squared, that means 2/3 equals x squared. Now this is another quadratic equation, and I hope that you recognize that it's a quadratic equation that's perfectly set up for the square root property. So to solve this, we're going to unsquare the variable and do plus or minus the square root of 2/3. So we really have two solutions here. Now this is not considered in simplest form because we have a fraction under the radical. And you may remember from working with radicals that you can't leave a fraction under a radical, and you also can't leave a radical in the denominator. So what we're going to do is split this one fraction under a radical into two separate radicals using the quotient rule, and then we will rationalize that denominator. So square root of 2/3 becomes square root of 2 over square root of 3. Don't lose your plus minus symbol. And now we need to eliminate this radical in the denominator. So we multiply top and bottom by square root of 3. And that's going to give us plus or minus square root of 6 in the top. And in the denominator, square root of 3 times square root of 3 is just 3. So this is fully simplified. And now let's do the same thing for the 1/4. So again, if we apply the square root property, we will unsquare the variable and we'll have plus or minus the square root of 1/4. Okay, now when we apply the quotient rule here to split this up into two separate radicals, we end up with plus or minus square root of 1 over square root of 4. And this is a little easier to handle than the one that we had before because both 1 and 4 are perfect squares. So we can simplify and eliminate the radicals completely. So this is going to give us plus or minus 1 over 2. Square root of 4 is 2. So our final solutions here are plus and minus square root of 6 over 3 and also plus and minus 1/2. Now this equation happens to be simple enough that you might see how you can solve it without doing a u substitution. Some people would feel perfectly comfortable factoring with the x to the fourth in place. So let's just try that. So we can say that 12x to the fourth splits into 4x squared times 3x squared. Notice that x squared times x squared would make x to the fourth. Now the signs need to be the same, and they both need to be minus, so we'll put our signs in place. And last times last is 2. I can't put the 2 here, I have to put it here. And let's make sure that outer plus inner adds up to negative 11x squared, and it does. So now we can say that if this times this equals 0, one of these factors has to be 0. Either 4x squared minus 1 equals 0, or 3x squared minus 2 equals 0. If 4x squared minus 1 equals 0, then we'll have to solve this little quadratic equation, and we could use the square root property to do it, but I noticed that it's a difference of squares. So I'm going to factor this 4x squared minus 1 into a sum and difference of the same two terms. So it factors into 2x minus 1 times 2x plus 1 equals 0. And then if this times this equals 0, one of the factors has to be 0. Either 2x minus 1 equals 0 or 2x plus 1 equals 0. If 2x minus 1 equals 0, then x equals 1/2. And if 2x plus 1 equals 0, then x equals negative 1/2. So there are two of our solutions. And now for this second factor, this is not a difference of squares, so it won't factor quite like this, but we can use the square root property to solve it. So to use the square root property, we want to isolate the x squared term. So we're going to have 3x squared equals 2, and then isolate the variable, so divide both sides by 3, and now unsquare the variable, and we'll have x equals plus or minus square root of 2/3, which we would have to rationalize like we did on the last slide. And so we end up with the same four solutions, but we just came at it without using the u substitution at all. I just wanted you to see how it can be done, but please make sure and read the instructions, and if a show work problem on a quiz or a test requires you to use a substitution, please make sure you use that substitution so you can get credit for your work, because if you don't follow the instructions, we cannot give you credit.